Hello, welcome to Chapter 5, Section 2, Properties of Quadratic Functions in Standard Form. In this example, we're going to talk about minimum and maximum values. This will be an important concept that you're going to study. We're going to introduce it here, and we're going to introduce it with quadratic functions. All quadratic functions, the graph, I should say, of quadratic functions makes what we've been calling a parabola, which is basically kind of like a U shape. So this is a smiley U shape, this is a frowny face U shape. The parabola goes one direction. As I go from left to right, I'm going down, then I get to the vertex and I change direction as I go back up. Okay? That point right there, how far up or down it is, we talked about the x being the x value, which is h, whatever that is, being the axis of symmetry. But the k tells me how far, in this case, down that I go. That's called the minimum. If I flip it and it opens downwards, I'm going up and then I go back down. The k now represents the maximum, the top of the hill, the bottom of the valley. In pre-calc next year, about a year from when you're learning this, you're going to be studying polynomial functions that have higher degree than 2. The degree is the highest exponent. These are all degree 2 because they're quadratic. And if you were to graph a cubic, you're going to end up with, in some cases, you're going to end up with kind of an S shape. So it'll go up, come down, and go back up. And you're going to learn about the pattern. We will get into it a little bit in this class, but you're really going to study it in pre-calculus. And then it becomes a very powerful idea in calculus. Because, and this is a spoiler alert, I can find what's called the derivative of this. And the derivative is kind of like the slope of a tangent line. And that's kind of hard to explain. But that basically means that if I lay a tangent line on here and I go, that tangent line is going to do this, and then it's going to go back up. Well, right here where the tangent has a slope of 0, that's going to tell me whether I have a maximum or a minimum. Same thing over here. That's a very important concept in calculus. So what we're doing is we're just kind of like dipping our toes into some math that you're going to be seeing a lot later. You don't need to know about tangent lines or derivatives or anything at all right now. But for me, as someone who has already been through those classes, it's great to look at this and go, this is where you're headed. So let me explain what's actually happening. If you have a graph that opens upward, in other words, the a is greater than 0. So the a is positive. Remember when we have f of x equals ax squared plus bx plus c. If the a is positive, it opens upwards. If that's the case, you have a minimum value, which is the bottom of the graph. There is no top of the graph. We talked about not putting arrows in here, and Dr. Berger's putting arrows in here. But if you remember, like the graphs I've shown you from Desmos, they don't have arrows. That means that it goes forever up, forever. Okay? I try to avoid using arrows because a lot of people like to stop them in the middle and draw arrows. Don't do that. If the a is negative, it opens downwards and I have a maximum. So how do I figure out where it is? It's whatever the k value is. So whether it's a minimum, if it opens upwards, you have a minimum. And if it opens downwards where a is negative, you have a maximum. But either way, it's always k, which is the value of the function. Okay, so let's do an example so that'll make a little bit more sense. All right, so here's my function. I have f of x equals 2x squared, subtract 2x plus 5. My a is 2. My b is going to be negative 2, and my c is going to be 5. I'm going to need those in just a moment. But the first thing I know is that my a is 2, that's positive, So it opens upwards. So that means that I have a minimum. But it's not enough just to say I have a minimum. Now I have to find out what it is. So I need to know where the vertex is, which basically means I need to go through all the properties we talked about. First of all, the axis of symmetry is x equals b over negative 2a. My b is negative 2. My a is 2, so that's 2 times 2. Negative 2 times 2 is negative 4. This tells me my axis of symmetry is x equals positive 1/2. Excuse me. Now I need to find the y value. I'm going to take that and put it in my function. And I get f of 1/2 equals 2 times 1/2 squared, subtract 2 times 1/2, plus 5. And again, if you want to use 0.5, you can. I'm not going to panic too much about the arithmetic. I'm going to show you this real quick. 2 times 0.5 squared, subtract 2 times 0.5, plus 5. And I get 4.5. So my vertex is 0.5, 4.5. And this is my minimum. Okay? Now, the other part of this says, what's the domain and what's the range? Okay? So I know my graph opens upwards, and my graph is going to look something like this. And I know this point right here, the vertex, is going to be 0.5 and 4.5. The domain, and this is going to be easy, never get this wrong, the domain of every quadratic function is always all real numbers. And you can write it like that, or you can just say all real numbers. Now you're probably wondering, why do we say real numbers instead of just all numbers? We'll get to that in Chapter 5, Section 5. Okay, so in like about 3 more weeks. Are there numbers that aren't real? Yes, there are. But you can just say all real numbers. And for our purposes right now, that means you can choose any x that you want. There's no restriction for what you pick for x. You can pick fractions, you can pick decimals, you can pick positives, you can pick negatives, anything. You can even put irrationals in there. That's fine. You're not going to break any rules. Okay? And the rules would be like dividing by 0, because you're not dividing, or square root of a negative number, which actually means something later. We'll talk about that. Now the range, this is a little tricky. Notice that the graph, wherever this is, and probably be about like this, okay? Notice that the graph has nothing below the vertex. It's only above the vertex. So the y values start at the y value of the vertex and go up. That means that all the y values are greater than or equal to the minimum. Okay, let's do a couple more. So a equals 1, b equals -6, and c equals 3. I want to find my axis of symmetry, which will tell me where the x value of my vertex is. One more time, it's b over -2a. That's -6 over -2 times 1. -2 times 1 is -2. -6 divided by -2 is +3. So my axis of symmetry is x equals 3. My vertex uses that x value, 3. But now I need to find my y value. I take my function. I find f of 3. This is 3 squared, subtract 6 times 3, plus 3. To be honest, I'm not even going to waste my time with the calculator because I can do this one. This is 9, subtract 18 plus 3. 9 plus 3 is 12. 12 take away 18 is negative 6. So my vertex is 3, negative 6. Now, knowing my vertex, I can answer all the other stuff. My A is positive, so I have a minimum. It opens upwards like a U or a smiley face. I have a minimum. So my minimum is negative 6, which is the y value of my vertex. My domain, always all real numbers. That's never going to change. And my range, I start at negative 6, which is the minimum, and I go up. Y is greater than or equal to negative 6. All right, and we'll quickly do this one. My A is negative 2. My B equals 0, because I don't have a x term. And my C is negative 4. This one opens downwards, which is going to look like this. So I'm going to have a maximum. I have a top of the hill, not a bottom of the hill. Let's figure out what the vertex is. Start with the axis symmetry. B over negative 2a, that's easy. X equals 0. I don't even have to do anything, because 0 divided by anything except 0. A cannot be 0. Remember, A cannot be 0, so you're not going to divide by 0. 0 divided by anything else is just going to be 0. Okay, that's cool. So my vertex, the x value is going to be 0. Now I got to find the y value. So this one's g, I almost called it f. G of x is going to be negative 2 times 0 squared, subtract 4. Well, that's easy. 0 squared is 0, negative 2 times 0 is 0. This is 0 subtract 4, which equals negative 4. Now, put it all together. I have the top of the graph, so I have a maximum. My maximum is negative 4. The domain, one more time, all real numbers. And my range, I'm going to start at negative 4, which is the maximum, and go down. So y is less than or equal to negative 4. All right, we'll see you in the next problem.